Good morning, guys. How y'all doing? Today we are going to start our investigation of ocean tides and what causes them. Our focus has been on the moon, the lunar cycle, the phases of the moon. And so this is connected to that because the ocean tides are caused by the gravity of the moon, and in some small part, also the gravity of the sun. But our focus here will be on how the moon's gravity affects the ocean tides. Now, some of you may have never been to the beach, and I understand that. Some of you have. So I threw in some pictures here to make sure that you understood what we were talking about. So up here, you'll see high tide. You can see if you look at this jetty of rocks that is jutting out into the water. As a comparison, you can see at high tide how high the water comes up the beach, and you can see at low tide how low the water is. And you can kind of see how the sand over here is different than the sand over here. The sand is, of course, rougher because people are walking on it at high tide and low tide, whereas the sand that is underneath where the water comes up for high tide is smooth because of the weathering action of the water. Here's another image of the difference between high tide on the left and low tide on the right. You see these houses as a frame of reference. Here, you can see at high tide how high the water comes up to the house, and then at low tide how far the water is away. And then here again, another picture to give you some idea of the difference. Now, different areas of the earth have different what we call tidal ranges, which is the difference between high tide and low tide, and we'll investigate that as we go through this presentation. Okay, so I'm not going to read this word for word. You all can do that, but it says basically that gravity is a long-range, non-contact force between any two objects with mass. So that means everything. You have mass, I have mass. The pen on my desk, the scissors on my desk, paper clips, small grains of dust, an atom. Everything that has mass has some gravity. The larger something is, the more gravity it has. But gravity is also based on the distance between two objects. So, for example, with our sun, earth, and moon, the sun has tremendously more gravity. I don't know if that's the right word, than the moon because of its size. But the moon's gravity affects us more, even though the moon's gravity is much less, because the moon is so much closer to us. So if we're measuring the effects of gravity on objects, it's not only the size of the objects, but also the distance between those objects. It's very similar to magnetism. When you look at whether or not one thing will pull something else, a magnet will pull something else towards it. There has to be a certain distance in between them before the magnetism actually starts to work. So again, distance is the most important thing because the moon is closer to us. The moon's gravity has a much larger effect on the ocean tides than the sun's. Now, the sun does help a little bit, kind of gives it a little bit of a boost. And we'll talk about when that happens here in just a second. So again, the moon's gravity not only pulls on the solid portion of the earth, but it also pulls on the liquid portion of the earth. Remember, the earth is 70% covered in water, and water is much easier and will show the effects of that pull more than the solid earth because water is fluid and moves a lot easier than the solid earth. Okay. So the moon's gravity tugs on the earth, and it basically causes the water to bulge. The earth continues to spin, however, but the water underneath the moon would be bulging. Now, if the moon is on the other side of the earth or at a right angle to the earth compared to the sun, the effects of that bulge are either heightened or lessened based on whether or not those three objects are in a straight line or whether they're in at right angles to each other. So this is just kind of an animation to show you that as the moon orbits the earth, that bulge kind of follows the moon. Okay. Now you will notice that there is another bulge opposite of the moon, and we'll talk about why that is here in just a second. But wherever this bulge is where it is high tide. Okay. So wherever that bulge goes, the bulge follows the moon around as it revolves around the earth. And then at these two locations that are perpendicular to that bulge is low tide. So if the earth spins in one day, basically what that means is that every day we get two high tides and two low tides. Okay. Two high tides and two low tides. All right. So here's a diagram to kind of slow things down for you a little bit. You'll see here the sun, moon, and earth are in a straight line. So the combination of both the sun's gravity and the moon's gravity tugging on the earth's tides are going to cause the high tide here to be a little bit bigger than normal. Okay. So this is what we call a spring tide, and we'll show you that in just a second. So that's going to be like a high tide on steroids. Okay. It's going to be higher than the normal highs. And when that happens, since the water is bulging more on the front side and back side of the earth, that means the low tide is going to be even lower here and here. Now, when the moon is at a right angle, we see this little right angle being formed by the sun, earth, and moon. Notice that high tide is still with the moon, but it's not going to be as high because it's only the moon, not the moon and the sun like it was on the left. And then low tide is not going to be as low, excuse me, because the moon is pulling up here and the sun is pulling here. So that's going to be a higher low tide than normal. Okay. All right. So there are 4 special tides. Now, again, every day, every beach has 2 highs and 2 lows for the most part. Well, there are some exceptions as always, but for the most part, every beach has 2 highs and 2 lows. But there are 4 times during the month where we get these special tides. And those special tides are called spring tides and neap tides. So here you can see in these diagrams, the spring tides are the highest of the highs and the lowest of the lows. Okay, so a good way to think about it is spring, meaning popping up higher. If you put springs on your shoes, you'd be able to jump higher. So a spring tide means higher highs and lower lows. Okay, and this is when the sun and the moon are working together. Okay, either they're in a straight line with each other with the moon in between the sun and the earth, or the moon is opposite of the sun. But in these 2 locations, this is going to be spring tides. Now, in this location here, this would be the full moon. We talked about the lunar cycle. Full moon is when the moon is on this side. And then the new moon is here. So spring tides always occur during the full and new moon of an area. Now, neap tides are the lowest of the highs and the highest of the lows. Okay. And the reason for that, again, is because now the sun and the moon are at right angles to one another. So the moon's gravity is tugging on the water this way, but the sun's gravity is tugging a little bit this way. And remember, even though the sun has more gravity, the distance that the sun is 93 million miles away, it doesn't have as large of an effect on our tides as the moon. Okay, so remember, distance is key. So the neap tides occur during the first quarter and the third quarter moon. Okay, so this would be the first quarter. This would be the third or the last quarter of the lunar cycle. Okay, so again, 90-degree angles. So whenever you see these at 90-degree angles. Now, again, remember, sometimes the moon may be right here. Okay, and so that still would be high tide, but it's not in a straight line or not in a 90-degree angle. So that would just be a regular high tide or a regular low tide. The spring tides and the neap tides are super tides or much less than super tides. Okay. All right. So this is a graph of high tide and low tide for Cosmos Bay in Alaska. And I chose this one simply because there was a very large tidal range. So a couple of things I want to talk to you about, because you may see a graph like this on your test. So this shows you how high. Notice there's 2 highs in this 24-hour period. Okay, so this is starting at midnight over here on the left, going all the way to midnight on the right. So the first high tide occurred right here, probably somewhere a little bit after 1 a.m. And then low tide occurred here close to 7 a.m. Okay, got to about 2 feet above normal, because 0 is 0. That's sea level. So even though it's still higher than sea level here, it's still the lowest point. And then by about, I'd say close to 1 o'clock, about 12 hours later, after the last high tide, now we have this high tide. And notice that it's higher than the first one. And again, because moonrise and moonset, this is the time that the moon was up. Okay. So this is when the moon was on the other side of the earth because of Earth's rotation. The earth is now rotated 12 hours. Now the moon is now right above that beach, and the moon is pulling up higher on the tide. And it got up to 18 feet above normal. And then after that, the low tide got really low at -2 or 2 feet underneath the normal. Okay, so 0 is normal, 2 feet would be -2 would be 2 feet below normal. So we call the top of the wave here, the top of this line here, a crest. We call the bottom of this a trough. And then the difference between the high tide and the low tide is what we call the tidal range. So here, 2 to 18, the tidal range here would be 16 feet. But the tidal range here would be 20 feet because it went from 18 down to -2. Okay. All right, so here's some other pictures of some of extreme high tides and low tides, and these are taken from the Bay of Fundy in Canada. So here you have the difference between low tide at the top and high tide at the bottom. High tide at the top, low tide here at the bottom. These two videos that are here, I'm not going to play them now. We'll talk about them during Zoom, but you're more than welcome to watch them. These are time-lapse, sped-up videos of the difference between high and low tide in the Bay of Fundy. This is Hopewell Rocks, also near the Bay of Fundy in Canada. And then this one here, which takes a little bit longer, is in France. And you notice all of these boats that are down here is basically sitting on the bottom. Eventually, all of these boats will be on the water. So if you get a chance, make sure you look through those 3 videos in the notes to get a better idea of it. Tomorrow, we'll talk more about local tides. And when I say local, I mean the beaches here in Texas, because we don't experience these huge differences between high and low tides. Okay. Because again, depending on the topography of the ocean floor and other factors, high tide and low tide can be extremely different in different areas. Okay. All right. So hopefully that explains it kind of in a nutshell. Again, if you have any questions, always let me know. And make sure that you answer the questions in the Check for Understanding in Schoology today. All right, guys, have a great day.